Safety Engineering, Management and Analytics welcomes you to this weekend talk series. So today we are in the third weekend with Professor Kumar with us, and I am Dr Mitra from Tata Steel, the session moderator, along with Mr. Ashish Garg, Ms. Sanjana Chaudhary, and Mr. Souvik Das from IIT Kharagpur, our joint session moderator. So we would like to welcome we have Professor Obi Krishna, convener of the weekend talks, and we have our expert speaker, Professor Uday Kumar, for today's weekend talks. So, Professor Kumar obtained his BTech mining from BHU and PhD in reliability and maintenance from Luleå University of Technology, Sweden. He is the chair professor of operation and maintenance engineering and director of Luleå Railway Research Center at LTU. Experience in research, consulting solutions to industrial problems directly or indirectly related to reliability and maintenance of engineering systems. And he has been awarded Nodia Science Foundation Award, significant contribution to science society. He is also Distinguished Alumnus Award at TBH. He is an elected member. So, we have such an expert speaker with this, Professor Maiti, Chairman of COE SEA, to welcome our expert speaker. Over to you, sir.
Yeah, okay. So, very good evening, afternoon, Professor Kumar, and good evening and good afternoon, good morning to the participants. Today the connectivity, probably there is little problem. I was not able to hear some of the time to mom also. So please excuse us for this probably connectivity problem, but we are trying to improve it. So Professor Uday Kumar does not require any introduction. Mom already has said some bit of Professor Uday Kumar, but only I don't want to extend this by introduction. Only I want to tell only one thing about Professor Kumar. Actually, when I was doing my PhD under Professor Ashish Bhattacharya in 1995, that time, then I started learning reliability from Professor Kumar's paper, published in Reliability Engineering and System Safety. I have gone through his PhD thesis also on during that time, and that was the starting point of my learning from reliability and maintenance point of view, which afterwards I have used in the safety engineering side. So he is a very well accomplished researcher, academician, as well as he has basically taken a lot of leadership positions also. And you know that safety is heavily dependent on maintenance, and reliability, maintainability, or maintenance, safety, there are common portion, that a lot of overlap also is there. So I'm 100% sure today you will be very much enriched by Professor Kumar's lecture, expert talk. And Professor Kumar is basically very well known in the area of reliability, operations and maintenance and safety engineering. Professor Kumar, please.
Okay, thank you. Okay. And I'm audible also, okay?
Yes, Professor Kumar, very much.
Okay, thank you, Dr. Mitra, Professor Maiti, and colleagues. It's a pleasure for me to share some of my experience in field of safety, I will call it. It is mostly will be built around the area of reliability and maintenance, as Professor Maiti explained to you. He said about that. So new technology empowered safety management. So I'll be touching on some of the issues, few challenges, and what is the future? What is the future we are looking? Because things are in transition, things are changing rapidly. So what are the future directions, and I'll be touching upon. So for 45 minutes, some will be more, some of the slides are just touching upon. I have 80, 90 slides, so it will be there. Before we start, always we try to say a few words about our institute, Luleå University of Technology. And our strength is like advanced cutting edge applied research. So if you talk about Luleå, it's a 50 years old now. We are celebrating 50 years. It was started in 1971. And Luleå is not like a IIT Kharagpur or IIT Kanpur or big university you people know about it. It's a very unknown, a small place. About 70,000 people live here. And when I first was coming to Luleå to do my PhD, so all the time I thought it is lying very near Stockholm. And I was searching in map, but I didn't find it. Then I saw it is up north. But at the same time, this Luleå is a hub of industrial hub of North Sweden, northern Sweden. All the industry like steel, mining, paper mills, like timbers, and nowadays IT hub. So it's a very dynamic city, and almost $50 billion investment is going on around this city. New type of plants like a hybrid, you might have heard, like a fossil-free steel production. Last year, LKAB, the mining company, the leading mining company in the world, and SSIB, Swedish Steel. So, India buys a lot of Swedish steel for defense purposes. I see many Indian ships here in the harbor and all. So they started a plant, what they call hybrid. They will use hydrogen instead of coal, and no coal in the steel production. And so it will break the water, get the hydrogen, use the oxygen for some other purposes, and hydrogen will be to free the oxygen F2O3, so it will become a water again. So that way you have achieving this. Then last month another company came in called H2 Steel, about 20 kilometers from Luleå. They also announced they will put their plant here. And LKAB 3 months ago announced that they will go completely fossil free by 2040, and they will be investing around $50 billion for whole process. LKAB mining company is owning this at least one plant here. So it's a lot of things are happening. Now, 2010, when Facebook was moving out of US, so they selected Luleå as their external base. So first data center was established in Luleå. There were many reasons. It is a cold little bit, energy was cheap, and there was no power failure in the last 30 years here. So that was some of the things they put. Then there are many industries are coming around that. So this is Luleå is small, but Luleå University is also known for doing a lot of applied research, and it is also called research here are mostly focused for industry and society. Means you have a strategic research focus only five years you have a time to 7 years for implementation, and there is a triple helix, very functioning triple helix model here: industry, government, and academia. And that was Luleå was placed here, Luleå University here. So research for industry and society, not for library. That's the driving force. And also any program we are developing, they are to create new jobs, new solution, not to seek jobs. So we tell our students, you should try to create some startups. They get a lot of help and all. So Luleå is known for creating so far successful 126 or 30 startups from here. And also a total 600 startups has been registered so far. Just outside there is a science park here. It started about 40 years ago also, that also. So it's a lot of ecosystem is very strong. Industry, government, and academia, they work together. Yeah, coming back to the topic of the day. So it's like when you want to employ new technology and want to empower any process, so you need a knowledge. But even greater knowledge is there, but you have to innovate it. So that system will be adopted by the society, by the industry and all. So knowledge and innovation, and then of course, technology and collaboration. As I was saying, collaboration is very important. Without collaboration, nothing is going to function. And collaboration is facilitated by government, and government has a special budget to facilitate through what we call innovation bridges. So government gives money to create innovation bridges, and then industry puts money and they take the research and convert them into the business. So research to business is one of the big, for the last 20-25 years, been much more focused in Sweden. And those who follow, Sweden has been always on top 5 in the world on innovation side, either second position, third positions or so. And Sweden is also always been on the engineering export side. There's a number of people living here, almost 10 million is our population here, but it has been listed as one of the engineering exporting company, leading engineering goods, and they export from here. And big companies like, ABB is a part of Sweden, Ericsson, SKF, the big any company. And a small company being, it produces many things. It produces fighter planes. It is the fourth largest producer of fighter planes in the world, Sweden. It also produces submarines. It is the third producer of submarine, or fourth it will be now. It is a producer of guns, Bofors gun, you may be knowing. And it's a lot of engineering, telephones and exchanges. And India has a very good cooperation with Sweden. Like our trains, old trains are from Swedish model, actually. Old ones, we are running electrical trains in Chittaranjan. They are from Sweden model or exchange. Many things are, we have a good connection between these two countries. Now coming to the safety risk due to human activities, I will be talking into three areas. One will be divided design. I is missing. I can correct it. One is human activities, like a human-induced risk. And second will be technology. It's not there listed. I'll be coming. And then natural processes. How human activities brings risk, safety risk, etc. to our life, to our industrial processes. And third one is a safety risk due to the what we call black swan events. We'll be talking about that. Let's describe first the black swan, and then I'll come back to you. You all might be knowing about this. For 2010, Taleb Nasib, he talked about this black swan events. That these are the events. It's very difficult to predict. All the science, logic, astrology get fail in predicting such events. And I will be having some examples of that, and also a little bit suggestion how to deal with black swan and all, with the help of technology. Okay, coming back to, you might have seen this. This is Morgan's framework figures describing what is human activities and what is natural processes. Human activities are like anything we do to develop a new system, like conceptualization is a human activity, designing, producing, constructing, operating, maintaining any engineering assets. And natural processes are like earthquake, tsunami, floods, anything, natural erosion, wind, anything you say, flow of water, snow, all these things are classified as a natural. And they all bring different types of risk. We know we don't need not explain what is earthquake and tsunami can introduce the risks. We need not. We'll be looking more on the some of the example of natural processes, and also we'll be looking into human activities that can introduce risk into the any process. Let's say transport process. So if I change anything, if I'm changing any maintenance plan of my tracks or my vehicle, what type of risk I'm putting into the business process or transport process that may lead to accidents. So, or what type of risk I'm buying out from through my activities like investment activities, new type of policies, etc. So we'll be looking into those things a little bit. It was Morgan. I used to teach many years ago, 93 to 97, about risk analysis and all. So that time I used to have this picture. This is like a risk matrix, and our goal is to minimize the probability through preventive measures. And also, if I can't minimize, reduce the risk of failure, risk of event taking place, unwanted event, then I will try to mitigate the measures. So this is a simple description of this. As Professor Maiti was saying, so I am very much in reliability. That was the foundation, and gradually migrated towards maintenance and safety. So if you look closely, the reliability, safety are closely related to each other. If something fails, it will have some implications, some impacts, and that may be safety, that will become accidents or incidents. What is the role of maintenance? So maintenance comes as a compensating function. There is unreliability, maintenance will try to compensate for it. Let it be natural processes, degradation due to natural processes leading to unreliability of a process or of an asset that may have a safety implication. So maintenance comes as a compensating factors, and maintenance can also bring risk that we'll be looking, because it's worth saying that about 20 to 30% of risk, all accidents in plant and chemical plants or even manufacturing plants are related to maintenance. Happens during the maintenance activities. Maintenance is very closely related to safety actually. If you delay the maintenance, there will be safety impact. There will be safety will be affected. If you do too much maintenance, that can create a safety issues. If you do a wrong maintenance, that can create the safety issue. If you do a poor maintenance, that may have a safety issues through reliability and all. So maintenance has a close relation to safety, and it comes as a compensating factor for unreliability of an assets. And that unreliability can be through natural processes or through human activities. So this is the relationship. This is one example, like if I'm designing, looking for a design flaws and all. So I think stress, this is a simple example, and this is my strength. I think when I design system looks like that, but with time there will be reduction in strength, and without knowing there will be a failure. Classic case used to be a mine winders actually. In South Africa, they noticed when they have a factor of safety 10 in the winders rope, it used to fail because there will be some failure in the strands. They will be not knowing. So strength of the rope used to go down, whereas the stress level was the same 1 ton or 2 tons you are lifting. So there was a chance of failure increases with time here. So this is the explanation and all. So time dependent stress buildup and all. Is it clear? Are you hearing me? Am I clear?
Yes, yes, sir. Yes.
Okay, good. And then reliability, I'm just building up a little bit on reliability concepts. Reliability to capture the safety risk. So if you are doing a reliability and safety, reliability analysis especially, so any risk introduced through engineering assets can be very easily captured. So you need to do reliability analysis for a safety assurance to ensure a high safety level and all. So this is just put an objective. You have a new model, develop a new model, or use the existing model, new data, or use the existing data. And nowadays, more and more data-driven decisions are being taken. So we'll be looking into some example on that. What is the data-driven and other parts? I said like reliability analysis. So when you are designing to eliminate design flaws, you need to do a lot more analysis during design phase. And when you look at the reliability, look at the cost and reliability and what is the state of the art material selection. So there are not many things, and we do a trade-off because we don't have a lot of money. So we have to do a trade-off with the cost benefit analysis and look into the life cycle cost of the system. Let it be road, let it be railway. So we put a value on the safety. Like we did some study in 2005 on the roads, safety of the road actually. On European highway, they wanted to put a divider in the middle. And they don't write on paper. During the meeting, we were told by DG, Director General was in the meeting, that each life is put 14, per person is 14 million crowns, is like roughly 10 crores rupees. We put a value on the life. One accident costs that much. One person dies, it costs to the society 14 billion Swedish crown. And based on that, what will be the cost of this divider putting throughout the widening of road and many things were there. So we calculated based on that, and we recommended that it is cheaper to put a divider so that you can achieve your target of. Sweden has still what they call zero vision, like a noll vision, or Swedish they say zero vision, that one day we should achieve a zero accident, no death. And used to be in 2003 or 4 about 600 deaths per year because very lot of people drive on the road. Now it has come down to 236 last year. So what we are trying to say, like Sweden is moving not as they expected. Target is 2030, but it will be very difficult to achieve. But it's still moving towards that day. So many systems like a car design, vehicle design, bridges, everything is taken into account. What should be the curve and all. So, but cost is one barrier. How much it should cost? Because finally, you use the same dollar or same crown. You can put that one in hospital. You can save more life there. So that's why sometimes we don't understand the political decision, but there is a lot more in-depth work is done behind that. Where this $1 I will put, so I can save more life. In India, it's worth putting a lot more in the healthcare system that we have seen during the pandemic than spending on parliament or something like that. That's my view. Or maybe building some new some like iPhone or something for future and all. Healthcare needs a lot more investment. Okay, then if I cannot design out failure, then I have to design for maintenance, because a lot more accident takes place during maintenance, as I said. So if I could design, so easy to inspect, easy to change, easy to look, it will reduce the number of accidents. It will reduce the safety incidents and all. And it should be definitely design parameters as called like a maintainability issues, and that has to have trade-off with reliability. If reliability is too good, you can put the things behind some cover or something, but if reliability is not good, it has to be easy to maintain, easy to change and all. So these are some of the issues directly related to safety from reliability. You do a lot more risk analysis, what risk you are putting by selecting that type of models, that type of methods, or what you are doing by selecting the method B or C or D. So you have to have a trade-off everywhere. Now, since we are talking maintenance, we come from maintenance area. So it's like a first commercial, this is a second commercial. Research for 5. So we have a group of strong 26 faculty, maintenance and reliability and condition monitoring and industrial AI, and working with asset management and people. I'm chair professor, I'm group head, and there are almost 20 approximately PhD students. And we have 4 adjunct professors from NASA, Palo Alto Research Center, GE, Alstom Trends, and Railway here. Five research professors are there. They facilitate, they spend a month or 2 here. You may be knowing, maybe Professor Mike and you may be knowing about this DNP Murthy. He was spending earlier every year one month here. It's good for us. He used to bring the culture of the Harvard and Harvard University, what they did, how they used to do PhD and all. That was good. Ashish, you may be knowing him. Maybe I don't know. DNP, Pramurthy we call him. So he has been spending. Our group, this is old pictures. We have a center called Luleå Railway Research Center. We manage it, but it's for whole university and industries. It's a triple helix. There are industries are member, then we are member, then government gives the money. And I don't know whether you look into the LinkedIn. I didn't share it. It got 150 million crowns. It's about 150 crores rupees. Building excellence in maintenance last 10 days ago from the Swedish government. Building excellence in railway maintenance, actually, I should say. And most of the focus will be on the developing AI capability, what we call industrial AI, where the operational technology will be merging with the information technology to achieve the scale of economy and all those things. I may be touching sometime again. Then we have a center for maintenance and industrial services. What is not railway is on this platform discussed. And then a special, like this is a time bound. Escape gave us about not a lot of money, 50 million Swedish crown they gave us for 5 years. They wanted to develop what we call a smart bearings here in our group here, our institute. So our electronics department, our cyber security, cyber what is called CPS, physical system department, and our computer science, maintenance, tribology, combined together, we started working for this center. SCAF has also center in Imperial College London on metallurgy, Cambridge, Imperial College is on tribology, and Cambridge, they have a center on metallurgy. And Tsinghua in China, I don't know whether you know Tsinghua University in China?
Yes, Professor, we know Professor Murthy also.
Yeah, okay, good. Tsinghua, I'm also visiting professor there actually in Tsinghua. It's a MIT of Asia, they are calling it, but I don't know how to call it. It's a huge. It looks, the campus and everything is different. So Tsinghua, they put the software, and Lulia was the maintenance actually. Yeah. And we did some work. I'll be showing some of the architecture and all what we have done. So this is our group. We have almost 40 projects are running. I sent you, Professor Maiti, our annual report digitally. Those are the projects listed we have. And then this is our what we call TRL level. We are working from 3 to 8. We have work on 8 actually. We developed the prototype also we have done in our lab. So research and innovation activities, new knowledge, methodology, technology to be explored, developed and assessed and used. All things. This is our focus. So we both market pool and technology pool and applied technology. We are have only one project here on TR level 2. I will be coming back. It's a nanotechnology actually for maintenance and safety. Rest is on the 3rd and 4th level. Applied research in condition monitoring applications, AI applications and all. So this is our research things. And we have produced about 8 books so far, 2 are in the press. So we call it, this is the first textbook in maintenance engineering. And handbook of industry for artificial, me and my colleague, most of time, I think I'm not co-author in this one, but rest I'm co-author. So this is some of the, I just want to see we have achieved. And we have our own journal, actually, our division journal. It's a division journal, actually. We created a division journal for 10 years ago. And we said, we had a vision when I started. The division was launched in 2001. I was alone. So I said, in 5 to 7 years, we should have our own journal also. If the Springer, Wiley, or elsewhere should publish it. So Springer was the easy one to deal. They are publishing. Then they wanted a society to be connected. So we got connected to, there is a small society in Delhi, SREQOM. You may not be knowing it. Reliability Engineering, Quality and Operation Management. That's based in New Delhi. So we connected to that and got approval. So Springer is printing. That's our logo is here. Our logo and Springer. We are the, it's almost going to the emerging science SCI index. 2000, this year they asked for evaluation. Hopefully it will become a science index this year. SCI Thomson Reuters is looking to that. So this is some of our background. Now coming back to the risk. And as I said, like risk introduced due to the design flaws. And classic example is, you may be knowing this, those who are working with Boeing and all. It's a 737 MAX plane where you cannot have control. The machine, the technology takes over you. It doesn't allow human to intervene. So just as symbolically, I put like a mobile telephone for a common man when I give lectures and all. We were very happy in 2004, 5, and 6, 7 came the 3G. Everyone was happy. But by 2020, 19, phone has taken over us. We feel uncomfortable. If I leave my phone somewhere, I remember I have gone home every time to bring the phone. I cannot live without mobile phone. You must be feeling the same thing. Many of you at least. We have become slave of technology. But technology also introduces risk because it lacks the actually creative spark of a human. A new situation comes, it won't be able to react, leading to accidents like this Max. You may be knowing better than me. And one of the guys said like a designed by clowns, supervised by monkey. It was in Fortune. Many times it was discussed. You may be knowing this part of the story. Then risk coming due to design flaws. Again, this is a classic in Sweden actually. We are the preferred support partner for Swedish aviation, military aviation aircraft, Saab Aerospace, which is also was listed number 2 in India when they were selecting the fighter planes, JAS Gripen. We have always some project like a pilot support, on-board pilot supports and all. What happens when the emergency comes, how pilot can deal with the situation. I have a group with aviation people, 4-5, they are leading it. And adjunct lecturer from Saab Aerospace in our group. They have done PhD with us and they become lecturers afterwards. So when you design, the problem with this plane, like this is a typical called Draken, Saab Draken. But now it has been the production has been stopped. In 70s, 6 pilots died actually in a period of 18 months approximately. What was happening? they could not visualize the weight on the wings when it is flying and doing turn maneuvering. So it used to crack. So there was a beam, the hole was really in a wrong way. So design for manufacturing is another thing, is very important. When you are designing something, you have to design for manufacturing so that robot can weld it properly. That's a key. And robot can drill holes properly. And there was some problem, robot could not reach. So there was a 1 millimeter deviations in the bolts and nuts was tightening. But it used to get loosened, then the pressure used to be on the beam and wing used to break. When it is on the very highest point, about 13, 14 kilometers and doing some sorties while coming down high speed, they meet the air, that was the problem. After death of 6 pilots, they stopped and started checking, they found the flaws and they corrected it. So it has been till 1996 and they took a new version, JAS Gripen 39, which is India has tested. There are 200 people in Bangalore of this company demonstrating these flights and all. One of my PhD students was, they have an office in Hyderabad. He was leading the group actually for support services. This is one design. So design issues, when is a designer, you look how safe is safe enough. You have to make, and you have to look at the cost. You have to go through the lowest possible tender because simple one bolt costs $9, $8. So you have to find a cheap one. Are we designing for no risk? That is the biggest risk actually. If you design something and declare there is no risk, be ready for the black swan. You will be ready for surprises. And what about black swan? As you see, earlier you saw, black swan, difficult to predict, rare surprises, but it is there, hiding. So if you give a chance, it will be there. You can't deal with that. So design has to deal many things. And of course, human errors will be looking at that. This is a human error, driving fail. And one of the human error is operational error is Piper Alpha. The people who read safety, they know that it was an error done during the maintenance. When they were doing maintenance for the safety valve, pressure valve actually, they put a blind head of the pipe which could not withstand the pressure of the oncoming. The coming gas was on supply in the next shift, and about 10 o'clock in the night, it exploded. And it got the spark from some motor, they say, the gas, and start burning. There was another problem, like operational problem. That was the hub for all the supply from different platforms in the nearby. So what happens when they could stop this supply from this platform, but other platforms were continuously sending the gas in the beginning, making the fire, as you can see in the figure. So human error related maintenance and operation both were connected to these accidents. And of course, we have to deal with that. And I don't want to talk, you know better, Bhopal disaster. That was also a human errors in maintenance, how water entered the tank. And of course, I was working that time in Hyderabad. I remember distinctly, 84 December, 3rd December night, the radio news came that this has taken place. We thought 10 people died or 20. It was a disaster. So these are the some of the things like can be connected to that. So the weakest link, if you look, is the humans. It can be human error in design, operation, and maintenance, leading to safety consequences. And human error has been studied in depth. And when I was doing my PhD, I took 2-3 courses on technical psychology. And one of the things I sitting in my head, I did a project work on that, like human errors and operating environment. If I have too much workload, I'm more likely to do mistakes. If I have too much variation in my work, I'm more likely to do mistakes. If I have too high salary, that is another funny thing. You simulated it. I'm likely to do more mistakes because my focus will go from the job. If the too good ergonomic condition, I'm not likely to do more mistakes, but I may not get more benefits out of that. So 9, what we call like 9 environmental factors that impact the mental well-being of a person, and that mental well-being connects to the human error or human reliability. So it is a very interesting study I did, and I must tell you, I got an offer to do PhD in psychology also, but that time I said no. I was doing already in reliability area and all. So psychological, like off late, human study, like weakest link in our new technology is there. Exactly same thing. Like you have to understand the human, and that is the weakest link in whole chain of new technology. Like a black swan, maybe remembering this is very fresh, 2002, a Indonesian plane. Why it is a black swan? The jet engine. This was 737 designed for it can deal with when it is landing up to 10 gram of water per cubic meter of air. What happened to this one? Suddenly both the engine flamed out. Flamed out means were slacked by something, and they found when they were checking there were 18 grams instead of 10 grams. Water has entered. So when it was going through the thunderstorm, it could suck lot of thunderstorm, like a small like ice pieces and all. It was never thought like that it will be taking so much. And then there was a pilot error. The angle you entered the thunderstorm area, leading to this crash, but nobody died. I think only one casualty. I was following that, so I remember this. It's there. It's one of the interesting black swan events. It should not have happened. There were two design flaws, because you can make it very easily the jet engine that it can withstand up to 18 to 20 gram of water per gift. It costs little bit money, of course. Or pilot could have avoided landing that point. But pilot was a smart. He could fly over two low-lying bridges and land up in a very shallow water, a small type of canal or something like that, or a small river. This is another was a Fukushima nuclear accident. This is a real black swan, natural disaster. We don't need to discuss. Quite fresh in our memory and all. Yeah. So now coming to the topic. This is a sorts of introduction, like introductory or like look into the problem in depth so we can find solution. So how can new technology can eliminate or mitigate the risk and facilitate trustworthy safety management? The word trustworthy is everything it includes. It is trustworthy means I can rely on it. I can be peaceful. I can sleep well. And even if I do some mistakes, even if there is an error, operational error, it will deal with that. Even there is a technological flaws, technology-induced error, it will be able to manage it. Even there is a design flaws, it should be able to manage. And even there is a maintenance flaw, it will be able to manage. Maintenance flaws, if I'm not fitting anything, like a pipe flange I told you in the Piper Alpha, by simple warning through the sensor, it could have been detected. But people didn't do it. There was no sensor on that. Similarly, like a plane, you know exactly today what is the weather. Now we have a fantastic climate change models. We can know from every minute when plane would have been entering, it could have seen through multi-physics modeling in real time that what is the amount of water will be entering the jet engine chamber. It's possible. It's not difficult. Now, coming to a little bit, earlier we were using like, in early days from 10,000 years, we're looking at the flight of birds, movements, and we were thinking that rain is going to come. We used to predict by seeing the movement of ants and insects. Now what we are doing today, we are trying to predict with the help of HoloLens, Google's Lens, or different types of visuals and all are there. So these are the new technology. How can we use this new technology to manage safety? And these technology are characterized by different industry, by different, what is called 4.0. Industry 4.0 gave mining 4.0, like everything is like connected remotely, operated by remote, asset management 4, manufacturing 4. In fact, I attended the very meeting by where German, I forgot his name, Boss, and they declared, they were invited by Swedish Innovation Government Agencies. I was in the meeting, and they declared that in 5 to 7 years, everyone will be using Industry 4.0. And then 2014, the German Chancellor, this Merkel, she announced that it will become what is called the foundation for the new industrialization of the world. But it is there, still we are moving, not completely there. And using those new technology, what we are trying to do, develop solutions that will facilitate safe working and safe management. So predictive technology, what is this new technology we are going to use for safety management or in maintenance? It is a predictive technology. And if I look the amount of work being done, like 90 billion euro has been pumped in by European Union for research on the predictive technology for agriculture, for healthcare is the most, all the money has gone to healthcare and industries and all. A lot more work is being done on this technology and all. Now, one of the predictive technologies, even better, the soft side is the what I was telling, collaboration. Collaboration in the safety in the industry, in a factory, industry, employee, and the government. And then also machine to machine collaboration. If you are getting to the advanced manufacturing 4.0, how machine is machine talking to machine, how machine is sending SMS or twittering that, hey, I am not feeling good. Are you the same? Other guy says, other machines, I am also not feeling good. Means some context has changed, raw material has changed in the supply. Or other guy says, okay, machine 2 says, I'm feeling good, so some local problem. Like that, we are trying to develop communication on our industrial AI platform. I will be coming back to what we call like AI factory and all. And then of course, human machine collaboration, that's critical. And it's not human machine interface. Now it is a human machine and interface. One person will be operating 20 machines, 10 machines, and that is a risk zone. That is what we call like a killing field for safety related issues and all. It will be a minefield if the person is not the right one. Because purpose of removing humans from the system is to ensure high reliability. But we became more and more dependent on the guy who's left in the system. So he should have a very high reliability. He should be almost superhuman. He should be able to read the things. He should not be able to be affected by too much variation in front of him in the screen or too much no activities. Not many things will be coming into the pictures now. Okay. Here are some of the, we are for railway, we are trying to develop what we call transformed assets, from integrated asset to using cloud computing and all those technology. So railway, we are trying not to optimize the track separately or the vehicles, joint optimization. So railway, vehicle owners, maybe managers and track owners, they have to talk to each other. They have to communicate with each other. If track is bad, in real time, vehicle will get the information. If vehicle bearing is not functioning, some will, track will get information that it's not damaged the track. So this collaboration is needed. This is a mining example because zero entry. What is happening in Kiruna mine? Mine is being operated from earlier. Now they have moved again to new building from 10th floor of an office underground. 7 big machines were operated. This is from I think mine actually. I don't have a. They are also trying to operate remotely using electrical catenary wires and all those things. So lot more things are being done here in Sweden. Sweden is a leader in advanced technology, underground mining. And first automatic train was run in 1976, developed by ASIA, now ABB, underground. It's still running. And now they are running what we call the difficulties. Standalone systems are okay, but how to run a fleet of machine in a autonomous mode? That's a challenge. It's still not solved. So one of the biggest challenge was the communication technology. Now with 5G network underground, hopefully it will be solved. Now I'll be coming back to like inspection and all how new technology. This is our framework. We are developing this every year, and this is a foundation for all our groups. So we have what we call like digitalization is the core of this framework. So you have to have a domain knowledge. If you want to develop safety solution, you must understand the area you are working. One of the reasons cited for failure of the GE Predicts platform, they put $100 million because they failed to understand the domain. Indian Railway was implementing in 2017. I was there because I'm connected with Indian Railway. I am a co-opted member of Technology Mission of Indian Railway, also Make in India program of Indian. Dr. Saraswati, he's a chairman of the committee, Niti Aayog person, and I'm a co-opted member working for that, and also in Technology Mission of India. So I was there in the engaged, but Predicts has never understood the mechanism, wheel-rail contact problems, and the program failed. So it was not implemented. And last year, finally, it was dropped. The whole program was sold from GE to a separate company. That's also owned by GE. They don't want to see that more. So these are very important. Domain knowledge you have to have. supportive technology. When you develop something, like I was telling, like many accidents do to take place due to failure in or due to design flaws. Design flaws can be now very well deal with the what we call computer aided engineering, not the design. Engineering looks into the context. It can integrate the temperature, rain, humidity, dust, etc. using multi-physics simulation and all. So multi-physics is being more and more being used to simulate the conditions, engineering situations and all in development of new technology. And of course, you can use AR, VR to look into the future and all. Then, of course, as I said, this is our core, the second one. Optimizing technology, RAMs, LCC, context-driven rule, condition-based maintenance, industrial AI. But last 4-5 years, 2016, we launched this transformative technology group in our group. And we start building competence in what we call industrial AI. Our AI is not applied AI. We call it industrial AI. They are operational technology, like a train is moving. What are the SCADA PLC system? How it is communicating with what we call like information technology. They have been living for last 50 years, I will call, separately. SCADA PLC since 69, IT since 50, 60, 70s. They have been there, but they live their own life in silos. What we are trying to do, merge them. Many companies are trying, not only we, so that when any change is taking place in maintenance plan, that will impact the operational technology. That will force the train to take a new type of decision, how to run it. So this is another core, domain and convergence of IoT for manufacturing, machine, etc. Okay, then transformative, I don't want to go, you all know what is IoT, digital twin, big data, cloud computing, 5G, AI. What we are trying to do, develop this predictive and prescriptive technology there. Predictive, everyone is working, but last 3-4 years, focus has come to prescriptive. I'll be going into a little more detail on that. And once we succeed with the transformative, it is cheap, easy to use, it will become disruptive. It will change the way things are managed, safety is managed, maintenance is managed, and all. So that's our framework, that's where we're working. This is an example of multi-physics modeling and all. This is another supportive technology, like person is working, but online he can find and by touch screen get all the information. This is also a human machine interface example. Optimizing, I talked to you. This is our area. We do a lot of work on that, innovations and all. RAMS 4. Actually, this concept, RAMS is a very common, and for European Union 2013, our group wrote the program for railway, not for the whole European Union. And we introduced this concept, we said RAM 4S for railway, shift to rail program, €1 billion program. And we introduced these two words, three actually, security, supportable, safety was there, reliability, availability, maintainability, and safety. So we introduced security also, because more and more digital platforms are being used, digital solutions are being introduced, etc. And then supportability and sustainability. Supportability, people do forget. Railways are distributed linear assets. It's not in one place. So where to put the people, or maintenance depot, where to place the maintenance people, where the mechanical, electrical staff should be standing. It's a key to making sure that train is moving as it is planned, in right time, in right way, with the right capacity on the network. Sustainability, everyone is talking nowadays. So we thought we'll put it like a grid, like a less, how maintenance can facilitate emission, less breakdown, because every breakdown, unplanned stop consumes more electricity, more power, more delays, more introduces diesel fuel consumption, because people starts moving and all. So we said like a good maintenance, good reliability can ensure also good sustainability. And this is, we have got the money for this from Swedish government. I said you just know 150 crores rupees for 10 years. How to use this one to build excellence in reliability, availability, and maintainability. Okay, RAMs, I will not get into, difficult to build the multiple failure modes, we don't know. Integration of context into rule estimation is a PHM actually, I should call it. It's a PHM we should call, RAMs and PHM. Transformative technology, already talked, build around all this data edge computing, analytical, digital twins and all. I'll take an example. So looking back, now I'm into transport. If you look back into the old industrialization in 1769 when steam power was developed, then 1869 electricity became the hub of the day-to-day business in manufacturing and all. People start producing, batch producing. So there was two things, mechanical and electrical power. 1869, third revolution called PLC came into that. Installation started in 60s. That's the rate. But first two were based on the powers, electrical and mechanical. These two were based on the data power. Even though PLC digitalization started in 2012, the real data power started being exploited. So now, new industrialization, that was the word used by Merkel in meeting, innovation based on data power. This is a pic I have taken from Ericsson's presentation. So now we are working in an area of data power. So in big data, we trust, everyone praise big data. Data-driven decisions, data-driven that, data-driven maintenance decisions. So most of the decisions are now being built around big data, how to use the power of data. So data is the new fuel to the AI engines. You are doing like you are sending drones in the inspection. So drone collects data and feeds that to AI engine, and data from the drones becomes fuel to the AI engine to take the right decision, take us to the right destination. This is the data analytics defines and decides business. These are the cuttings from 16, 16, 15 are there. Now, so when you are doing data-driven approach, there are many challenges. Extremely many challenges. There are many challenges in data-driven approach. You may be seeing in Indian news, I was seeing Twitter government wants to take control. People are sharing. So one is a technological challenge. What is technology? If I have to introduce data-driven, let's say railway, and there are some private operators, why should I share my data? How can I make my data secure? So cyber security is becoming a very big issue. And this is our AI factory. This is a big issue for us. So safety, security, and sharing is a challenge. Safety, like by data, your fingerprints, people know exactly which machine you are operating. By hacking, they can know your machine can be hacked from anywhere, and it can have safety implications. Like train is moving, hacker can enter and take control of the train or the signal, leading to safety implications. That's a big, big shock value of the whole data-driven approach. Same, security is the how to stop these happenings. So somebody on what is called unauthorized people taking control of the things and sharing. Why people should share data? What is the drive with that? So we identified 3 challenges, and this is 2 months ago I was asked by what is the Organization of Economic and Cooperation Development, OECD, to help them developing the white paper on this. So we did it actually from here. I had a workshop for 62 countries were participating members. So I gave a workshop. This was the only, I had it half an hour. This is the core of that presentation. How data-driven approach and what are the challenges, future challenges. So cyber security was one business model. You need a business challenge. Government cannot collect all the data. So why I should collect data and give it to other people? There should be trust and there should be traction. Means I should get something out of it. There should be drive to get some money based. It should be service so I can sell it. And then users. Why should I buy? I should have money, resources, I find some interest. So trust around the data provider, data processor or data platform, and data users. So that's the big trust has to be there. But biggest hindrance is the governance. Like a technology is jumping, galloping, but regulations are going with we call it like a old pace, like a bullock cart's speed. It is still not digitalized. So digital transformation of governance is key for getting to the data-driven approach. All these 3 things will have at least greater impact on the all safety, like safety related systems like a railway, transport, nuclear power plants, guard it. What are the penalty if you don't follow the regulatory? So we have to have a regulatory framework in place. But at the same time, Data democratization is another area. Everybody should have equal access to the data. Why should Mr. X should get and I should not get the data? How can I authorize for that? How can I keep track? So everything is chaotic right now due to government not being very clear. This is the government, societal. Then it is within the organization. Who should get the data? Who should have the authorization to make changes into safety critical system? Because safety critical systems can change in a nuclear power plant or in a transport. It can create a havoc. So this is some of the very briefly I'll touching here. But we prepare a report for this International Transport Forum professional board within the Organization of Economic Development about 3 weeks ago. So data-driven or model-based. More and more people are moving towards data-driven in day-to-day life. But if you talk about the industrial things, it should be model-based. Okay, digital twin can aid to our safety because we can in twins we can see what is happening and we can context the parameters and all hybrid approach and all. Okay, now coming to some examples. This is our SKF framework we developed here in Luleå Railway Research. And that was the main business for SKF. So what SKF did, we developed the foundation for condition monitoring, what we call like hybrid models, and try to find through the whole cycle. Bearings will, one example, let me bring the bearings here. Bearings here will be able to read the track geometry problem, track failure, rails condition, and connect the LKAB is a mining company and Traffic Bharket is our railway department. Sent to both for, that was the purpose. So that derailment can be avoided and all. It was tested, it failed twice because communication could not be done. Closed room communication is big issue. And for goods train, energy harvesting. It didn't work as we were thinking. So it's still under the prototype development. So this is supposed to prevent derailment of derailment of railway, goods wagon and passenger trains. What we do here, we create what we call noncasting, and then we create forecast. Noncasting, where I am standing, what is my status, and where I am heading. So it has both descriptive analytics, diagnostics, prognostics, and prescriptive. It's not enough to only give a prognostic what to be done, and this is depicted here. So this is like you see what has happened, what will happen, and what should I do. Then you get the best solution by these analytics. Okay, idea was like when to stop the train. You can see example two. Just 1 minute. I'll
Screenshot ଚିପିକି ରଖିବ ଅଛି କଣ ଚିପିକି ରଖି ପାରିବନି କି
actually somebody is talking. Please mute your mic. This is one also we developed for the safety also. This is the test actually. Oh, it's not working. Actually, we are testing here, like trying to locate the missing fasteners in the snow through eddy currents and all. And it has been trained through the AI data-driven approach so that high-speed train, when it is moving, it can record that 5, 6, how many fasteners are missing, so that train cannot derail. You know, many derailment takes place with the fasteners. Yeah. So this is one. Up to 250 kilometers our prototype can detect it. It has been developed with the help of Bombardier, Alstom, and patent by our group. Our division our institute has the patent on that. Example 3, it is another what we call track geometry modeling. You see the symbolic example here. In a bed, it's like in forest area, how the track goes. You cannot run it. So what we are trying to do, develop a machine learning models for that, identifying all this. Even 1 millimeter track is deviating, I can be able to know it when train is moving. So on board identification, location of track geometry parameters. Track is widened by 1 millimeter due to some ground movements, due to some earthquake or something. We'll be able to detect it. So these are the track geometry like instrumentation, maintenance limit and safety limit. An example is like if the degradations is like this in the track, This is the maintenance limit, black one. Then action should be done. It is not allowed to touch the safety limit. This is the government limit regulations. If you come there, you cannot run on the track area. So this is the one example. Warning, safety solutions are not pure data driven. That you should remember. There are lot many things, culture, safety, governance, and I will be coming to this challenges. Legacy system, whatever new technology we implement, people still keep the old one and try to implement the new one, and that creates the problem. People keep the old one, like a Swedish government last year said they need $89 billion to change entire system, go to the new type of 5G nets and all, and government has no money. Then another group recommended that borrow the money from World Bank, it will be much cheaper, return on investment will be in 5 years. So government took the decision to start changing all legacy system. That's one example. Standardization. This is very important for safety. Why do mistakes take place in maintenance? Or why do we do mistakes while track and in railway especially? This is the reason. Cyber security we talk, I will not talk. Third one is these three are related. Human factors, organization, and this one. Things are changing so much. How new things are, because next new things fatigue we call it, like everyday new things. How can we manage new technology? How can we, it's difficult to pay attention to all. So there are solutions, like you see the pictures using the humanoid robots to monitor. This is in Kiruna mine, we are planning to deploy one robots that will keep track of all data, because it's difficult, there's a less variation, too little variation, human cannot notice it if there is any small changes, but robot can do it. That's the purpose. Culture, it's very difficult to change the culture actually, and that's one of the weakest link in organization. Whatever rules you bring, whatever machine you bring, whatever instrumentation you do, if people are not resistant towards the new technology, they will never use it, or they will use it half-hearted and leading to accidents or catastrophic failure and all. Okay, then also like three more ethical issues and privacy. People don't want to share the data. Taxation is another issue. Demographic changes. There are a lot many things will come through the new technology. Operational challenges. I leave it. I have been talking. Future direction, that will be of interest. What we are trying to do here in our group, we are working a lot with how can we monitor the, as you say, like a fastener was one example. Another one was like bearings. Third one is like a nanotechnology actually. That I have been driving personally. How can nanotechnology can be used for monitoring the fill conditions, like condition of a high-speed trains, and at nano level, at 10 to 10, because any fatigue, crack growth has to do changing in the atomic structure. So if I could monitor the change in atomic structure at that level, I can give at least 1 hour, half an hour, 10 minutes extra for a high-speed train. It's much cheaper way. So I had a discussion with one person, professor in Georgia Tech 2 years ago, last year again, and he's a Chinese, Professor Yongjiang. He was nominated for Nobel Prize. He came to Lulio, and he says, yes, we can monitor it. So he's working. I know you can monitor what we call nanoampere, like strain gauges, but how to bring precursor, that's the challenge. How to bring the information up, that's we are working on that. These are the new future direction. Idea is to measure the train, bogie, and wheels, high speed. Okay, but what is happening again? Hanging on. So, future development, we are also putting like a new scanners and all in front of the all high speed trains or ordinary trains, so they can they can look at the data, collect the data about the bogie and the wheels, and send to the people who are relevant, like a maintenance department or engineers of the trains and all. And this is another project. 2 years ago, we started what we call AI factory for railway, and this is focused on scanning technology. When train comes, this is Alstom. This is Alstom train coming to the workshop. A scanner I was telling, it will take the scan the train, and it will analytics will perform what is the condition of bearing, axle, bogie, and some braking system, and that will be transferred to the right guy here through different analytics and all. This is the future, and this has attracted a lot more focus in the Sweden and in outside the Sweden. It has been listed into Sweden's one of the future potential project that will bring change into the railway system and all, railway monitoring and all. It was listed into our Science Academy list of future last March. Looking, this is like a scanner I was telling, wayside a scanner up to 250. And this is like a workshop a scanner I was showing into the pictures. It will look like this. It will give you like green performance targets, green. Regulatory compliance, green. And if I have to next visit 1000, only it says remaining useful life is 840. Or if it is 600 hours, depending on it will become red, yellow or green. So we can do it. Health advisory. This is a AR, VR being used. This is from our lab. We are seeing this whole track has been scanned through the leader by the railway, and then data we are used by this HoloLens from the lab. We are helping to repair, identifying, and that has saved a lot of accident actually. We are implementing the auto it is in a implementation demonstration from lab is over. Now it is being implemented in southern part of Sweden on AI factory platform. This is like you can see how the high is looking, the real and the scanned one. Then also in the mining, drones are being used now to monitor the walls and all. And recently, 3 months ago, they bought LKB with the help of our robotics department. Boston Dynamics, this you might be knowing, this is a spot. It can go to the mine phase, zero entry. If you do blasting, then a spot goes, test the smoke, looks for the roof, test the dust level, gas level, scan the walls, and if needed, it can carry the drones on the back and put the drones to take a near vision. If it cannot climb on the walls, this can walk on the stairs, but not on the walls and all. It's a Boston Dynamics adopted to the LKB requirements. This is like on BP is already using this. I had a nice presentation for the gas leak and all. They are sniffing through this. And drones are used for everywhere. In India also I have heard that they're using for this high voltage high voltage grids monitoring, and also the this and that it's a lot of accident do take place during this monitoring of this one. Every year in Sweden, on average 1 to 2 people die actually. So now for the last year, no death, no accidents, no one has fallen. So that is good. This is a railway. What is railway doing? Railway and road department, they are collecting a lot of data from GPS, condition of the road, and sending through this to the central, and accordingly, traffic is monitored actually. Traffic monitor, roads are maintained, everything is done. So that's the null vision, zero vision I was telling. Government has put a lot of money because during winter it becomes slippery. Immediately sand trucks will be sent from the local area, and they will sand the area, turning will be monitored and all. And this is another example, like how it goes. These are the trucks and all. Traffic work that I was showing there. These are government. Maintenance contractor will move with the trucks because maintenance is completely distributed and outsourced to the local area. You cannot maintain 1400 by government, they say. Chill out how data is moving and flying. Okay, now development and direction, mobility, flexibility, robotics, power of big data and cloud and edge computing will be good. Now computing Leela. Whatever we do, the new technology or the AI may not have the creative spark of human brains. Sophia can do many things, but she lacks still the, the Johnson Hanson technology from Hong Kong they are developed. They still lack the creative spark of the human. So human is still supreme. Let us hope it will be better. Now I'm coming to end. Safety first. That should be our motto. That's the motto of the traffic work. We are following. They gave us a lot of money, so we have to follow them. So safety first. And new technology provides a window for monitoring, predicting, and managing safety. Thank you.
Thanks a lot, sir. Very, very relevant and informative session. You can see the chat box also. It's full of great compliments for this session.
Yeah, we can start questioning. Let me close so I can see people, and good.
So the session I would like to hand over to Sovik and Sinjana for taking up the Q&A.
Feel free, anything you can ask. Reliability, maintenance, cost, risk, safety,
Okay. It's an excellent talk by Uday, Professor Kumar. Very nice to see you, and you speak Yeah, and then I remember the way in your laboratory you work there, and your team. I really very happy to. And then some of the presentations here, I saw some of the work I did not know before, but most of the things I know your work. But it is really you have simultaneously put some of the very big and issues, particularly that our related to our data, related to our domain expertise requirement, and integrating to the that's your supportive technology and the domain technology, and then this, of course, gives some of the points to ponder, particularly how we are going to mitigate our risk in our Indian conditions. Well, thank you very much. You have given a very nice. I put some of the queries there, but I hope we will be getting a very good answers. Your lecture itself has placed a lot of pondering points to us. Thank you. Thank you for the nice.
So
Thank you,
thank
Professor.
you. Yes. Thank you, Professor Kumar, for your highly informative talk on safety, reliability, and maintenance issues. Now, there is a lot of questions in the chat box, but due to time constraint, we will be able to take only a few questions. So
Yes,
let me start with the first question. The first question is, what are the hazards associated during metro rail maintenance? Could you please explain ramps on metro rail project maintenance?
yeah, okay. Metro rails and all. Actually, metro rail is not like what we call like a service public platforms. Metro rail has a one special unique things because braking distance is very like you brake and often you accelerate and de-accelerate there. And it is a lot more focused. Like when we study metro rails, our focus is on to look into the security and safety parts is the most important thing. Braking distance. So headway distance between two. What we are doing with MTR actually. MTR is a Hong Kong company. They are operating the Swedish metro rails. So focus become like how can we maintain the headway at the same time punctuality is another critical area because every 2 minutes trains are coming. People are even though not bothered about the 2 minutes and all. So we did incident analysis actually because we don't want any stoppage. Anything identified. So morning, 2 o'clock, night, the metro stops in Stockholm, 5 o'clock. You do all those things. So what we call like opportunity-based maintenance there. Like anything doubt, you do the maintenance. You understand? Even if there is a less likelihood of any failure, anything, you change them. And following that, what happens? The contract, it was a 12 non-planned stop. It went only 7 non-planned stop. So it was better performance than the contract actually. So this is like a in common way we use the like a mean time between failure, common headway, unplanned stoppages that we're looking. So we didn't do the analysis of reliability calculation and model.
Okay. Thank you, Professor Kumar, for nice explanation. Now the next question is AI is the final solution for replacing the human error in the prediction, identification, and solve the safety related issues?
No,
Will AI take emotional, sentimental decisions as human take?
I had a slide like it lacks the creative spark of human. And there will be black swans, there will be natural disasters, there will be design flaws. And I can tell you, I was in China, in Singapore, I was giving lecture there for 2 years ago, no, last year actually, January. And AI team is very strong in Singapore, I can tell you. And there we traveled back to Sweden and there was a AI benchmarking exercise between Sweden and China. And right now, China is the leader. US and China, some people say earlier people used to travel from Sweden to Palo Alto, now they travel to Beijing actually, and Shenzhen. So like Huawei and all, I've been to Shenzhen, it looks totally. So what is happening in AI? AI will be a sad day. And Elon Musk is driving that. It'll be sad that AI takes over us. Like I had a picture, if you remember, mobile phone taking over us. So the day AI takes over, that will not be good for the humanity actually. And because AI can be useful, it is useful. but it cannot replace the human because human are creating it. It's learning. And I asked the question, the person who was heading the China team, he's a president of China AI development group. Told me in the meeting, Science Academy, there was a benchmark. He says, we in China don't think anything is like going to happen. It is likelihood there it will be stopped.
Okay.
So answer to your question, no, it will never take over our everything. But it will make our life easier, and definitely we should be more, we should use it smartly. That only thing I can tell you. It's a lot of work, a lot of decision. That's why European Union took a framework in May, what we call trustworthy AI. You know, trustworthy. You can do a lot of things, but trustworthy, why I had a word this one, means I can trust it. It will do what I want to do it. It will listen to my command. I have actually slide, actually, I killed it. I am AI, you have created me, I will serve you, I will manage you and manage your world. That's the dangerous part. I will manage you. That I don't want AI should do.
Yes, sir. Thank you for this nice answer. Then one more question we are taking. How human error is linked with companies' working culture and challenges before India?
India, I worked 7 years in India actually, and company culture has a direct impact on the accidents actually, let me tell you. It is absolutely vital point. Like if in a company, the culture is like, if I see something risky, if I tell to a company, if the culture is that, immediately it should be removed, that risk. If culture is not there, people just say, okay, fix something and do your job, or you should not bother, I will take care of that. And still in India, some places like cost is important, like production, but people forget to learn the indirect cost of an accidents in life. So culture in India, no. Sweden, it's a very, whole Scandinavia, I will say, or Nordic country, it's a very good here, extremely good. The value I told you is, I was talking to you about accidents and a life, value of a personal life, indirectly. 14 million Swedish crown, 2005. Means we don't want any accident on the road. It's a loss to society.
Yes, sir. Thank you for a nice answer. So now definitely participants are going to be benefited with this talk. And now I would like to hand over the session to Ms. Mitra. So, yeah, thank you. Thank you, sir. Yes,
Thank you,
over
sir,
to you,
but
ma'am.
I'm bubbling with a question. So I would
Yes.
like to ask one question.
Yes. Please,
Sir,
please go ahead.
every change, yes, sir. So, sir, every change brings risk, right? Like every
Yes.
technological change
Yes.
brings. Every personal change also, sir, brings induces risk in the system. So, in developing countries like India, sir, in industries we have the attrition rate of contract employees are very high. So
Yeah.
where people come and live in. So, what are the challenges in implementing AI in that? Because I would just like to quote some of the examples from steel industry, sir. Like PPE compliance, we have tried to monitor through AI, and that has helped. In COVID, sir, we have tried to monitor the gathering of the people in shutdowns and major shutdowns through AI. So that has helped a lot. We have also gone to the extent of mask compliance through AI, sir. Where, but of course, we are doing it from the audit point of view. But that has really helped a lot, and also to the department and to the organization. But I would like to, I think it will definitely be a challenge in case of access control and also, where I think the attrition rate of contract employees is quite high. So how to, what's the way forward in those cases? That's the question.
Actually, it's a more of a political answer I will give you. It's like the two things here. One is like when we are focusing on like implementation of AI. So often what happens, because in a regulatory regime, we focus on solution, not on the objective. You understand the difference? Like a solution, I want a safe working condition, okay? And then what? There's a regulatory compliance. So inspector comes that you have checked this one, you fill the form, he goes back home. But objective, like I want no accidents. forms, and that is much beyond those solutions and all. So that culture is lacking. So when you come like this migratory, like as you were talking, it will be difficult to bring the cultural shift. Like you want to change management, the word you use it. Change management with the technology and change management, they are going together actually. Actually, we are working a lot on change management, how to change the people's thinking, the way of life. I had this like organizational changes and all. And organization is a big barrier. We were not knowing actually. We're thinking that human is the barrier. No, organization is even bigger barrier. Because a person wants to change, organization will not allow him to change, even in Scandinavia. So in a country like India, we need little strict solution, not the objective. Here we are operating on the objective side. Solutions we don't look. We look of solution as only a small part of the getting a safe working place. Okay. It is a political answer. I didn't give you a full answer because you need a lot more compliance, governance, and all those things.
Yes,
And
yes.
transparent governance. I don't want to get into those details.
Thank you, sir. Thanks a lot. So, sir, we come to the end of this Q&A, but I think many people are bubbling with questions, but because of shortage of time, but wonderful session, sir. So, sir, next we are moving on to the formal vote of thanks. I would request Professor Ovi Krishna, who is the convener of this Weekend Talk series, to propose formal vote of thanks. Over to you, sir.
Professor Uday Kumar, I'm so happy. We have said these weekend talks are for academicians, practitioners, like students, researchers. You have really given this talk which is useful to whole sector of the people. See, more than 50% are from industries. They're all enjoying it. Mom Mitra is from Tata Steel, which is one of the benchmark for the safety in the world. That's why she talked something on the AI. You'll not get in many industries in India. Tata Steel is emerging into AI industry 4.0, all these things in terms of safety. Sir, I'm so enlightened with your speech. I'm from Center of Excellence. I work with Professor Maiti. The topics which you have touched, the right from maintenance, reliability, safety, everything. I am also a maintenance man. I worked in maintenance. I worked in operations. Finally, I came to Tata. I was in DuPont. Many things, cultural safety, behavioral safety, everything you mixed in your talk. You should have been given 1 week for explaining all these things to us. We have really made we are really made injustice by giving one hour covering such a topic. You're in what way I should express my thanks, I don't know. From COE, we'll definitely want to be in touch with you. We want your cooperation, you want your coordination, your blessings. COE in IIT Kharagpur is a toddler. It's only 1 year old. So as Professor Ashish Bhattacharya said, we'll be working with you. You're doing great work. You'll be one of our mentor for our COE. After all, Professor Maiti is your good friend. Professor Pathak is your good friend. Yep. All good friends will join together. Thank you very much, sir. Thank you very much again from the participants with the claps. I want to thank you for your great speech. Yeah. And the participants, I'm so happy you so actively participated in the chat box. I was reading all the questions. If those questions are answered, again, it will become a big research paper itself. And the monitors, who are monitoring the whole session, Mom Mitra from Tata Steel and my scholars, you did a great job. And I want to thank the participant. Today we have around 220 participants. Your participation will motivate us, and our speakers will be more motivated to share with you if you participate in big quantities. Thank you very much. Thank you all. Thank you all. Okay. Thank you, Pathak. Thank you, Professor Pathak.
Yeah, I would also like to thank Professor Maiti for giving this opportunity to share some of things.
Thank you, Professor.
Miss Mitra, it was good feedback, and actually I was in Tata for digital transformation of your production line. Actually, with the technology, I was a consultant to a consultant. So I spent 2-3 days I was staying and looked into your line, Mr. Ashish Gupta, and he was the vice president that time. Something he was doing. Okay. I spent some time there actually.
One thing
There
is,
was
Professor
a
Kumar is
conference also.
still our co-PI of a project of IIT Kharagpur. He's still working with us.
Oh, great.
Great, sir. Actually, Professor Kumar is so nice, and there are a lot of commonalities in our lab also. We have virtual reality lab, analytics lab. So definitely, we want your help, support.
Definitely. We will work. Actually, I come to India 5-6 times actually, meeting the railway board. But last year I didn't go anytime. So once I start, I was planning to come in July. So maybe I will make a visit to. I have a project with Kharagpur actually, not me.
Yes.
Make a visit there if it was.
So there are many participants from other IITs and other academic institutions, including I think Department of Atomic Energy. So everybody enjoyed your lecture, we are sure. So definitely we are thankful to Professor Kumar as well as all the participants and other stalwarts in this particular area and other areas. I think with this, Professor Kumar, we conclude the today's session. And Professor Krishna, is it fine or you?
Yeah, it's fine.
Thanks.